As we have already discussed in second stage that how we should move from mathematical model along with the information algorithm, which is written mostly in English like language, but we have to convert that into kind of a programming, any kind of a programming. You just think about any programming language, how it should be written there. That's how we have to use. And abstract data type we will be using, we are using in second stage is something abstract is it is data type collection of data type. Okay, that's how the abstract data type we mean. That's how we have discussed and we have understood. And most importantly, when we are talking about abstract data, sometimes you need a contiguous recording of keeping up data, storing up data, or maybe you want some kind of operation on it, and those kind of things we collect together and we have operations on it, and that's what we call as a abstract data type. So the abstract data type is not being implemented yet. We need to look at that how you wanted to have a abstract data type. For example, it is a set is having some kind of a unique values only. So you have decided in the list that I have data elements or data items in a list of data types where the data has to be unique. Then we should look at it as a set, and how the set has to is implemented in programming language, that we will see later. But currently what we have seen in the second stage is more to do with what is the abstract data type we wanted to use. Here we wanted to use some kind of a list, and we also wanted to use the set, because the reason being that all the vertex yeah, because it is all terms, basically traffic terms. So traffic term will remain unique only, they cannot be duplicated, right? So definitely we have to keep them in the set, and also list of things because we want to operate them on those data, so we wanted to keep it as a list as well. So we are keeping that as a list or as a set, but we are ensuring that there is not no duplication into this one. So operation purpose we are using only kind of a list and set. Okay, these are the two things. So how this abstract data type being implemented in programming language, and those are called data structures. That is what is called data structure. So those data structures we will be using for a list. For example, item number of items in the list, items in the, we can implement, we can store that as an array, we can store that as a linked list, we can store that as a stack, or we can store that as a queue. So many things are there. We will discuss that in the upcoming videos on sessions. But definitely this is how the list we should think about when we are implementing an abstract data type. When we are going to data structure, we have to see that how mind of abstract data type I thought of like a set, how it is implemented in a data structure. If it is not, maybe we can create one kind of a data structure where we will take care of all those operations for that particular data type is being implemented. So that will be used as a data structure in for that programming language. Then coming to the third stage. In the third stage, what we are doing is we choose implementation of each abstract data type and write a procedure and various operations around it. So let us go to stage 3. Okay. So when you are going to stage 3, okay, let us go to stage 3. Here stage 2 is done. That's how we written. Then what is the stage 3? Stage 3 is abstract data type used during more informal language. Okay. And we'll convert it into data structure implemented in the programming language. And once we started the writing the in the language, we use data structure which is provided by the language, programming language. And the program written will need further refined because it is not the final one. You look into that one, you will see that you will see that it is actually not the final one. You have to still refine it, but at least you have a skeleton which can be implemented in any programming language whichever you wanted to. So that's how we are going to learn it, but some of the things are not being there. We need to find out how it is being implemented. Okay. Then coming to this part, like the actual implementation part, what we have learned in the previous traffic signal algorithm is that whenever all the vertex are there, okay, all the permissible vertex are maintained in a vertex, and one vertex connected to another vertex by a edge, and that edge is nothing but it is not permissible. When two vertex are linked by a line, that means they are not permissible simultaneously. So that's how we are going to we have written the program. How will you do this one? Okay, in this case, for example, we don't have a graph. In some programming language, graph is directly not implemented. Then we can keep that in a list. In a list, we can have all that graph. So that graph will have all the vertex. Here nothing, but actually speaking, this is not G, but it should be vertex only. Vertex of the graph. Similarly, we can have another list called edge. Edge is like all the link between two vertex. So which is not permissible simultaneously. That is what we are putting in the list of edges. Third thing is that list of new color. So whenever we are coming inside, new color is always empty because we are going with the new color each time. Whenever you are coming inside this program, for example, you come inside the program, we wanted to color the first time. First time we came in and we wanted to color the vertex which is green. So there is a logic, right? We already know the logic that every all the independent all the vertex which are not linked to each other will be turned as green. So we are green this one. Then next time when you come, we will say that new color is empty and this color will be yellow next time. Third time you are coming, it is red. So each time when you are coming, you call for this one. Okay, you can say that, for example, string, okay, color. Say color. Which color you wanted to check? So that color, the green color, coming back, you store it into green color. Then you are coming next time, going back, it is in red color, you store it in red color. So each time in the previous any other program, you are from where you are calling this program, there you will mention that which color you wanted to complete this part. So when you are coming here, okay, new color is empty. Okay, then coming boolean is found, and boolean we call declare is found, and b is first uncolored vertex in G. For example, first time you are coming, the whole graph is not colored at all. So first time you are coming, so AB it is taken as AB. Then AB it will go inside. First time it will come inside in the graph. Okay, new color, nothing is colored. Okay, nothing is colored. For example, nothing is colored. You just check it this. Okay, let me take this one. Okay, put it over here so that it is easy for you to understand. Okay, easy to understand this part. Okay, so take AB first one, but nothing is colored. Now AB, okay, AB you make it green first. Okay, first there is no color, no new color, green is not there, right? First V has come, W first vertex in the new color is empty, so it's not null. So boolean is false, color. So AB is colored. First time is AB is colored. Then it comes to and then in the loop again. It goes back and get the AC. AC. It will come not null. So we will check that AC and AB, that is V and GW, are connected. No, not connected. So that means AC can be colored as green. Then comes AD. Is AD, it will come V as V in the AD. Okay. Then it will come inside. Then you will check with it not null, not null, because AB and AC is already there in the color, right? W in the color. So AB and AC. So for each one, it will check AB AD connected. No, it will go to next W, right? Next color. Then AC AD connected. No, not connected. Not connected. Then it will come is null. It is null because we already saw both two. Then it is null. Then it will come found false. So color AD. Similarly, when you are coming, you come to BC. So BC we find out. Okay, BC null. Then get inside. First vertex in the new color. While W is equal to null. So AB, AC, AD, BA are colored green. Now BC. Is BC connected to AB? Yes. So it is true. So when it is true, it will not color. Then it will go to BD. Is BD connected to AB, AC? Yes. Then it will come to DA. Is connected to AB? No. It is connected to BAC? Yes. So that's how it will go through the loop. So we are creating two loops. One is going through the whole list of things. Second is that we are checking whether the vertex that is coming is any link with the color which is assigned. So green is done. Then we will go back to the calling program. Wherever it is called from the main program, it will go back. Then green color is done. It will store green color into one bucket. Then it will call, okay, now you take the color yellow and color it out. Then it will come and check here. Okay. Then it will come and it will take only those list of vertices which is not colored. Okay, those vertices which are not colored, those all edges will be there, right? Those colors are which are not. Then it will take one uncolored, first uncolored vertex from G. So it will take the first uncolored out of in that particular dish, which one is the uncolored one. It will take that one. Or you can have list having all this one. Whenever there is a vertex that comes in, you go and check in this new color, the new color which is there in the new color green. So green color, you will check whether this vertex is present. If it is present, leave it. Only those which are not colored, that is what is come inside. Then you'll go inside and check everything in the new color, which is yellow. Okay, in the yellow color, again BC, yellow color is not null. Sorry, it is null because BC in that new color yellow, that nothing is there. When BC comes in, nothing is there. It will false. So it will be colored BC as yellow. Then we'll go to BD. Is BD connected to BC? No. BD is connected to AB, but not to BC. We have seen that one. These new things we have taken out. We are going with BC. Then we'll go to BD. Is BD connected to BC, which is yellow color? No. So it will be yellow. Similarly, coming to DA, is DA connected to BC or DA connected to BD? Yes, BD connected, so DA cannot be yellow. Similarly, DB, is DB connected to BC? Yes. Is DC connected to any of these things? DC was already green because we have seen that one. We have gone through all those things. So DC is already green earlier. Now coming to EB, sorry, EA, is EA connected to BC or BD? Right, BC or BD? No, E is not connected to BC or BD. So definitely this can be yellow because they are connected to AB, that's why they are not green. So they are not connected to BC or BD, so they can be yellow. Similarly, for each time color you choose, green color come inside, make the all the vertices which should be green. Then you make yellow color, then all the vertices should be yellow. Then the red color will come in and ensure that all the colors are, yeah, red. So that's how we will color all those codings. Okay, besides that, there are some extra colors will be there. Extra colors, for example, if you look at, for example, here it is not possible. Let me take this part. Okay, okay, take this one. Show you this here. Just check it out. Here I have here, no need to go there. Okay, here you just check it out. when b when AB, AC, AD and all, for example, BC, BD, EA, for example, BC, BD and EA. So BC is this way, BD is this way, and EA is this way, right? EA is this way. While going through this one, BC, BD and BA, what are the turns that one can take without hindering all these people? Okay, so BC is going, BD is going this way, okay, and B, sorry, EA. Okay. In this case, definitely BA without any problem can go. BC, BD, and EA. So BA can go this way. Okay, right side driving. EA can go. Let us see here. Let us see that if it is allowed. So when we are doing this one, BC, BD, EA, red color, second color I mean to say, BA is allowed. Just look at this. BA is allowed. BC, BD, and okay, here. Take this one and put it over here. We can check this one. It's easy. Okay. Okay. Now just check it out. Okay. BC, BD, EA. So BC, BD, and EA. It allows BA. I told you, right? BA, it is allowed. No issues. This way, right side driving and right side driving. This is right. So there is no hindrance. DC is also allowed. These are the extra. DC is allowed because BC is going, BD is going. But here, DC is no hindrance, right? Here it is coming, right side driving, go into right side, done. Similarly, ED can be also done because there is no hindrance. BD is going, ED can go. So those are called extras. So that is not there in the graph. If you look at the BS, sorry, those are there in the graph, but they are independent. They can run anytime. BA, BC, sorry, BA, ED, and what more? You can check that one. BA, DC, ED. DC and ED. Just check it out. ED, where is ED? Is ED, DC, and BA. These are independent. You just look at this. These are all independent. There is no, they don't have any difficulty while going through. But when you coming to the next one, for example, DA and DB, then it allows other things like BA, DC, ED is almost always there. BA, DC, and ED. BA, DC, and ED. There are sometimes it is allowing other extras also. These extras we have to find out and put it in the as an extra. So those extra we can say that okay, these are allowed because those are all already green. If you look at it, they are already marked as green. If you look at these two are marked as green. BA, DC, ED already marked as green. BA, DC, ED is already marked as green. So that will always there because they don't have any connection to anybody. Those terms. Only thing is that we have to look at AD and EA. So in these cases where we have these two terms are also allowed. So that's how we can check it. DA, DB, DA and DB having one color. So when it's DA and DB is going on, then what is additional? AD. So AD can go. Right? DA is going on. This side, right side driving. If DA is going on, then AD will go. Right? No issues basically. From here it is coming, here it is going. Similarly, DB is going. So DB is this side, right side, right? DB, right side driving. So when it is right side driving is allowed, then sorry, right side driving is this and this is right side. So this right side driving is allowed, then definitely at that point of time, AD is allowed, ED is also allowed. ED from here it will come, it will go. So AD is going on, DA is coming and AD is going. So these people who are coming this way, they can go into this way. Whereas EA, they can also go. Other things are same. BA, BD, CED, they can very well move without any hindrance because they are independent. If you look at here, they are independent. They can move at any point of time. So they are allowed always. That's how we have calculated. We have put the programming language, and that's how we will color it. That's how we will color it. So coloring should be based on the connection between vertex to vertex. Okay, then they are not allowed. If it is independent, they are extra. Okay, BA, DC, ED are extra, and sometimes few other terms are also allowed when allowing for other colors as well, other traffic also it is allowed. So we have to check that and we will mention that in this particular list. Okay, in this particular list of things, and that has to be part of this list. Okay, so then we can make an extra turns among those particular turns, and we'll ensure that when I'm allowing BC, BD, and DA, sorry, BC, BD, and EA, I will allow other three also. So I don't have any problem. So those are the extras we will calculate. We will keep that in another. We will add to the colored list, even though they are green. They will be colored in. They will be part of red. In this red also, extra turns are allowed. Okay, those will be put it in the list. You can make an extra list, so it will connected to a red list with the extra list, a green list with the extra list, yellow list with the extra list, but blue list there is no extra. The reason being that when it is going on, there is nothing we can move. BA, BC, BD, anyway we'll first one it is coming, we made it blue. We made it blue already. So these blues are allowed here, these blues are allowed here, the blues are allowed here. Some of them which are part of this particular group can also be allowed here, like AD, for example, AD green, that is allowed. Here also you can say EA. Where is EA? EA is red. Here red is allowed. So just look at the traffic and we add those extras. Along with this is allowed. So in the particular color scheme, in the new color scheme, you will add those extras to ensure that those will be allowed at particular time. That's how the algorithm has written here. The while loop For color blue, it will come and go through and color those which are independent, which are not connected to each other. Then it will come with green. Then again, it will take out all the blue ones first. Okay, it will go take the all the blue ones first. That's why it is mentioned first uncolored vertex of G. So it will go to the vertex which is uncolored. Whichever is uncolored, it will go into this one. Whichever is colored, it will filter out. That's how what you have to again implement here. The that we have to filter out all the vertex which is already colored. So that we have to take out. Here you will say if B, so you will say that B, if B is colored, then move. Okay, then move to next one. If it is colored, move. BC is not colored, come inside. That's how we will uh, color this graph, and we will use that for the traffic signal. The output should be as we discuss, as we are going to discuss. That's how it should be. Here we are calling each time. We are calling each time this program to see if we can make we can color the vertex as per the algorithm. Okay, this is little bit more refined, so you can take this one. It is more refined one. So more refined. And here again, when you refine more, this will be replaced with another while loop. Will go through that. If colored, v if colored, then go to next v, then next v if colored. For example, I'll write down here, for example, v colored vertex. Okay, okay, do sorry, uh, while uh, color buttocks is not null. You don't have to say, just take the vertex from the vertices. Okay, you just color check if v is color, v is uncolored, uncolored. Okay, here and this is fine. Maybe you can put, okay, put here, you can put another one. Okay, so if b is uncolored, then don't, if it b is uncolored, then go inside. If it is colored, go to the, sorry, b is next color. What for the b next? Okay, here you can put another. Okay, here you complete this if condition over here. Here you complete the if condition. Here you started, it will end here. If it is uncolored, go inside. If it is colored, we next but uncolored vertex, then go inside. Then again it will go through this one. So whenever you find something colored, then you come out. Whenever it is uncolored, go inside, because that is what we have to color in the green. So each time you call with different color, you check the color. Okay, if it is colored, then it will go inside. If it is not colored, it will go inside. If it is colored, it will come out. For example, you send a red. Okay, it will anyway, it find out that there is a red color, then you don't get inside, right? Why to process the same data again? It will not come as the same data. For example, here if you look at here, look, you come for red for BC. Okay, and the BC is done, then you won't get BC again, you'll get BD. Right, that's how it should be. Okay, thank you.